that sometimes we face, because you'll be tempted, or you are tempted to copy exactly what you see. But it is always good that you get one paper or two papers, or even three papers, which are going to be your primary articles that will serve as a guide to whatever you are writing. Yeah, so if you want to work on fuzzy synthetic evaluation, there are three papers I will recommend to you. One of the papers was written by Dr. Ibrahim Wuni, and it's on quantitative evaluation and ranking of critical success factors of modular integrated construction projects, which we will use it in this masterclass. And then there are other two papers which were written by Robert Osechi on PPP projects. And then there's also another paper which was written by Dr. Akomea. Akomea also wrote about PPP projects, but his work was more related to water projects, the water sector. So you can get these three papers, and based on these three papers, you can learn how to go about doing fuzzy synthetic evaluation. Yeah, so get them. Then also, what you can also do is that before you start doing this fuzzy synthetic evaluation, you can also decide to do you can do generic reading about fuzzy synthetic evaluation. So what is fuzzy logic? What is fuzzy synthetic evaluation? Because we have different types of fuzzy. There are so many types of fuzzy. So you need to know why we do fuzzy synthetic evaluation. So you can decide to read about that. And then once you are done, then you need to also identify the tools. So in doing fuzzy synthetic evaluation, what tools do you need? What software do you need? So you need to also know that. Okay, so yeah, basically these are the things I would say that you have to do. Okay, so I'll go straight to the point so that we don't waste too much time, because almost everything I'm going to teach here, I've put them in the videos. So if you want to get more of that, when we are done, you can go and watch the videos in addition. Because I've done 3 videos on fuzzy synthetic evaluation, 3 different videos. So you can watch more. But here I'm just going to give you something like a summary of all that we have done. Okay, so if you want to do a fuzzy synthetic evaluation, what you have to do is that, especially if you want to use fuzzy synthetic evaluation to write your article, the first thing that you have to do is, first, you need to do a literature review. You need to conduct a literature review. So conduct a literature review. So when you conduct a literature review, which I will even say that, in fact, all studies, including your thesis, if you want to write a good thesis, you want to write a good article, if you want to write something good, always look at what people have done already concerning that subject. Very important. So if you want to write about something like climate change, you want to write about climate change, first find out what people have already done on climate change. And if you want to find out what people have done on climate change, the only place where you can find out where people have done something about that is to just look at the past literature, the existing literature, what people have done before. So that is the reason why we do literature review. So literature review is not like maybe you want to conduct literature review and write literature review papers and write literature review papers. You conduct a literature review for a purpose. It forms the foundation of your research. So first, conduct a literature review. So when you conduct the literature review, just like this topic where Dr. Wuni was trying to find out the critical success factors. So he looked at the past literature, and based on the past literature, he was able to come out with these potential success factors. And these are the sources. So this is what I'm talking about. So you look at the past literature, Then you look at what people have done, and based on what people have done, you identify the things that you want to identify. And this is related to, or this will be related to the kind of objective that you have set for yourself. Yeah. So it's not always the case that also understand it's not always the case that every study you have to identify critical success factors. Okay. Like a study that I'm conducting with a group of people currently, we are writing about electric vehicle ready buildings. We are almost done with that paper. Electric vehicles ready buildings. So, and in that paper, we are trying to find out how project management practices are going to shape the way buildings are constructed, so that in future, when people buy their electric cars, they can have access to charge, access to plugs, access to electricity, access to whatever, to charge their electric vehicles. Because currently, most of the buildings that we have, we only have the plugs for our laptops, our TVs, and our fridges. But most houses don't have plugs that you can plug your car and charge it if you have an electric vehicle. If you want to charge your electric vehicle, what you have to do is you have to go to electric vehicle station, which is almost like going to a fuel station. Currently, that's what we have. So our study is trying to look at how, if you are a project manager, how you build a house, how you build an office, and then you leave spaces where people can charge their electric vehicles. It's a fantastic study, actually. So in this study, for example, we are looking at the studies that people have already conducted on this subject. And based on that, we have extracted very important themes from what people have done. And these themes are going to inform us to advise project managers that when they are building houses, the new houses that they are building, they should leave a space where people can have plugs where they can charge their electric vehicles and all that. Yeah, so that's
just a question.
Okay.
Is it our research topic?
Yeah, it's a research topic. We are almost done with the paper. It's a literature review that we have conducted. We are almost done.
Oh, wow. Okay.
Yeah.
And then is it do we have data, or is it an SLR paper?
For now, it's a
Can you hear me? Yes,
Can
you
you
are
hear
back.
from me?
Yes,
Sorry.
yes, you are back. That's fine.
Yeah,
So
I'm
is
sorry
it a
about that.
SLR paper or empirical paper?
This is a literature review paper for now. Because
Okay,
this is the new area. This is the new area. One, the electric vehicle itself is a new thing that is
okay.
coming.
Yes. So is it going to be only limited to, like, the implication will be limited to people who are using electrical vehicles?
Yes. So what we are
Okay.
trying to do is that we are trying to advise project managers
Yes.
or project management organizations or firms or
Yes.
professionals that they
Yes.
should learn this, because the time is coming where if you are building somebody's house, the person will demand that you have to leave a space where the
Yes.
person
Yes.
charge their cars.
Okay. I see.
Yes.
I see.
Yes. So that's what we are doing. Because
That's
currently
an emergent topic.
it's an emerging topic. It's new, because even in
Yeah.
Australia, it's really a new thing that is coming up. It's extremely new.
Yes, I have seen many petrol stations, they are started building those car charger things. Previously, they didn't have. Yeah. Yeah,
Yeah.
good.
Yeah. So it's something fantastic, which I think in future, maybe Dr. Roxana, we can look at something like that, and I think we may get some funding to support us to research about it, because it's a new thing.
Yes.
It's something that the Australian government is very interested in. And it has something to do with climate change and cutting.
Yes, of course. They goes back to the sustainability things,
Yeah.
SDGs. Yeah. Yep. Good. Thanks.
Yeah, thank you. So something like this, you can conduct a review and look at what people have done on it. And based on what people have done, then you can also extract important information, which will help you to conduct your study. So literature review is not done because we just want to do literature review. So you have to understand it. So once the literature review is done, the next step is that you go ahead and then conduct an empirical survey, try to get empirical data. So the empirical data can be two. It can be, let me take it from the basic one that we know. You can take it from the primary source, or you can take it from the secondary source. The primary source is where you use things like interviews, focus group discussion, survey. These are primary data. And normally we consider this data, sorry for the word data, in Australia we say data, but say data. Anyway, so this is something that you do for the first time. For the first time, in a sense that you are the first person, or in one way or the other, you are the first person who is approaching people to ask them what they think about what you are doing. But if you want to go the other way, this is where you use what we call secondary data. With the secondary data, you can take it from some of these well-known institutions, their website, like World Bank. If you go to the World Bank website right now, you can get data on the climate change. You can get data on COVID-19, the number of people who died, like World Health Organization, if you go to their website. These data are things that people have already collected. You are not the first person who is collecting it. Somebody has done work on it. So it's normally called a secondary data, including internet information and all that. From internet information, literature review, literature, they are all secondary data. Even including the literature that we are using for this, our work, or the literature that we normally use for our literature review, talking about the data. They are also secondary. They are secondary in a sense that somebody has already done something on it and it has been published online, and you are going to take it and use it for your study. So you are not the first person who conducted and put together that data. Somebody did that work. That is why we call them bibliographic database or academic database, including the Scopus, the Web of Science, the Google Scholar, the EBSCOhost, the PubMed, the Medline, and the rest, the ProQuest. So these are the databases where you can get the data from. They are secondary. Okay, so that's how you have to understand it. So this is literature review. So first, you have to conduct a literature review. So if you want to identify factors, conduct a literature review, identify the factors that you want to identify. Then from there, you move on to the next step. So now let's assume that the literature review has been conducted, and this is the data that we were able to get from the literature review. This is what we got. So these are the potential success factors. So the question is, what next? The next thing is to translate this into a questionnaire, put them in a questionnaire. Or if you want to go the interview way, you can also do the same. Or just like what Dr. Roxana did recently, I think interviews, right? Yes, interview. So the same. So either you go the interview way, focus group discussion way, or any other.
And I can help with the ethics kind of things.
And ethics. And ethics as well. Yeah. Well, one thing about Australia is that if you are going to collect any data, it's not only even primary data. And you need to get ethics. And what is ethics? Ethics is we are just trying to check whatever you are going to put out there, whether it is really, really true, whether it is safe, it is not going to harm anybody, and so forth and so forth. That's all about the ethics. And Australia is compulsory. You can't do any study, any empirical study in Australia without doing ethics. It's likely you are going to be questioned. I don't know about UK and co, but I think it will also be the same there. And they also follow the same this thing. Yeah. So the next thing is put these success factors into a questionnaire. Yes. So some of you, I sent you questionnaires and you saw this, and not the one I sent you. Some of you have even done this before yourself. You have done this before, where you constructed or you designed a survey questionnaire. So you know what I'm talking about. If you want me to give you an example, I can give you an example. So let me go back and give you one example about this questionnaire. I have one questionnaire here. I just want to show you one of them so that you get an idea about what I'm talking about. Another means by which I can show you this is also take you to my website. A minute. Okay, I have one here. I just want to show you how the survey, that if in case maybe you have not seen something like this before. So this is an example of a survey questionnaire. Okay, so in a survey questionnaire, normally you have an aspect which will talk about the basic information about the participants or the respondents. So maybe what is your highest educational qualification? Where do you work? Which industry are you coming from? What is your job title? How many years have you worked? These are basic information about the respondents. And then from there, you come to the main thing. So for example, with this survey, we're trying to look at the circular economy model for PPP infrastructure projects. So there are questions on that. And then I think we also had a section where I asked about, do you consider these circular models as important? Okay, these are the models. And then I have an aspect which talk about the success factors. So with the success factors, what you can do is that you can decide to rank them. And by ranking them, you are giving it an ordinal touch. An ordinal touch, that will take me to types of data ranking. We have different ways by which we rank that data. So your data can be numerical. In the numerical, we have two types of numerical data. Your data can be ratio or it can be an interval. So you can read about that. And then we also have an ordinal data, and then we have the nominal data. An example of a nominal data is what is your gender? I'm a male, I'm this. That's a nominal. And then an example of an ordinal data is ranking them in this form, where you want to rank, maybe in your class, who came first, who came second, when you were in high school, we have the numerical data. Numerical data can be like, what is your age? How old are you? Interval, you can look at it, or ratio rather. Ratio, you can look at it from the point of like, what is the current temperature? What is the current temperature now in Ghana? What is the current temperature now in Sydney? That's at 3:39 p.m. on the 9th of September 2023. What is the current? That's an example of a ratio data. So you need to understand these basic things, because these ranking of data, or we also call them the level of data, will inform you as to the kind of data analysis tool that you have to choose for your data analysis. Yeah. Because if you are having an ordinal data, if your data is an ordinal data, there are certain tools that you cannot use to analyze your data. And if you have data, nominal. So let me put them in the chat box so that Those of you who want to take notes can take notes. So we have the nominal, we have the ordinal, and then we have the numerical. But then normally the numerical, we have two types of numerical. We have the ratio and then the interval. Okay, so read about them because these things will inform you as to what kind of data analysis tool that you have to use. Because if you're analyzing something like gender, you don't need something like regression and correlation and all that. You need just a simple descriptive analysis to describe them, as to, like, you try to find out how many people are males and how many people are females. And that's it. You are done. You don't really need correlation and all that. When it comes to correlation and then standard deviation, the mean, the mode, the median, we have the data that we use for them. For median, for example, median is very good for ordinal data. Median. And then the mean is normally good for numerical data. Yeah. These are some of them. I don't want to go into them because this is also another lesson that maybe I will take you through. So you need to design your questionnaire like this. So what you have to do is, let me come back to the paper that we are using. So when you get you extract this from the literature review. Okay, so here I think you got about 28 or 30 something like that. There are many, but the next question that you have to ask yourself is, okay, yes, now you have put all these success factors into your questionnaire, as you can see it from here. It's like this. You have put them in there and you have ranked them. Good. But the question is, are all these factors important to the geographical setting that you are conducting the study? That's the next question that you have to ask yourself. So if your answer is, some of these factors, they will apply well, or they will do well in Australia, in the advanced world. Some of these factors will also do well in developing countries. Okay, so because we have geographical settings and geographical differences, it is good for you to find out what the experts in that industry they think about that survey. So that will lead us to what we call the pilot testing. So some of you have heard of pilot testing. I want to do pilot testing of my survey. So that's all about this pilot testing. So what you have to do is that once you put it in the survey, give it to an expert in that area. So you can, for example, if I'm taking Ghana, you can organize Ghana Institute of Engineers. You can pick about 5 engineers if your study is about the projects that are constructed by Ghana Institute of Engineers. Pick about 5 of them, and then send this survey to them as a pilot test, and then let them comment on it. So what you are likely to get from the pilot testing is that some of them will say that some of these factors, we are sorry, they don't apply to Ghana. Take them out. Some of them will also suggest to you that you have to modify the factors so that they will suit what is going on in Ghana. So you get that thing. So this is what we call the pilot testing. And it is always good to do pilot testing. Pilot testing can also be done with academic experts. Or you can do it combining the two. Combining academic experts and then those in the industry. So you can pick some academic experts and you can also pick some of the industry experts. So you can pick about 5 industry experts, 2 academic experts. Then you put them together, you send the survey to them, you ask them to comment on the survey. So it's likely by the end of the test, which you shouldn't take a very long time, it should take you about a week, 2, or maximum a month. Once you get their feedback, once you get their comments, modify the survey. So once again, I'm going to take you to the survey. So modify the survey. So it's possible this first point, it's possible some of them will suggest this first point, some of them will suggest that combine this first success factor to combine them, the two of them, combine the two, the first one and the second one together, because maybe to them, they think that, or they know that from their experience, they know that these 2 factors are the same. I'm just saying as an example, I'm not saying they are the same, but just an example I'm citing. Okay, so it's always good you conduct what we call pilot tests. So go out there, give your survey to people. Yeah. So once they are done and the people, your team that you are working with, they are also okay with the survey, then the next thing is you have to distribute it. So the question is, how are you going to distribute your survey, the questionnaire survey? There are so many ways by which you can distribute your questionnaire survey. Let me start from the manual, physical way of going about distributing your survey. So you can decide to give your survey out. First, you print them. So you print, and this will come with some cost. So if you have money, you do that. And some of you too, maybe you have the opportunity to print them for free. But some of the schools, some of the universities, they allow you to print for free. So you print them for free, you go out there, your targeted respondents, you give it to them, then you just, once they respond, then you come back. You collect all of them together, then you come back to come and do your data analysis. Another way by which you can also distribute your surveys through emails. Another way by which you can do this is by using, nowadays we have software like SurveyMonkey. We have the Quatrix. And I will encourage each and everyone here, even though that one also, I mean, these ones also come with some level of cost. If you have the opportunity, if you have that access, I will encourage you to use the SurveyMonkey and then the Quatrix and other platforms, because you save money and time. You save the hassle of going around looking for people to respond to your survey. So all that you have to do is sit at the comfort of your home, then you just click on an email, you send an email, then you just give it to them. And then the respondents will say, okay, so I'm done with how you distribute it. But the question is, how do you get the respondent, which we also call them the participants? So the name or the word participant, respondent, they are the same. So how do I get the participants? How do I get them? There are so many ways by which you can gather your participants. Okay, when I was doing my PhD, I had an encounter because in my case, that was the time that COVID-19, this COVID-19 was fresh in the system. And I was planning to go to Ghana. In fact, I was supposed to move from here to Ghana around December 2020 to start collecting my data. But this was the time that and then there was this COVID restrictions, you can't travel to Australia. Was impossible or was not possible. It was out. So the question is, then how were you able to gather the people? And at the same time, how were you able to distribute your data, your questionnaire to them for them to fill them for you? So this is what my supervisors suggested. So they suggested that I go to LinkedIn. So some of you too, you can take notes, you can do the same. You can go to LinkedIn, any survey that you want to conduct. So look at the people who are related or connected to the study or to whatever you are trying to work on. And then find out who are interested in this survey. So for example, if your research is on banking, go online and then check people's profiles. Courtesy of LinkedIn, it's easy for you nowadays to check people's profiles as to who they are and who they work for and where they work, their work experience and all that, they are there. So check these profiles and then send them something like a DM, direct messages. So invite them that you want to conduct or you are conducting a research and you are the data collection stage and you need them to respond to a survey that you have designed. So find a way. It all come down to how you send messages to them, because some people, we are living in a world now that people are scammers nowadays. We have a lot of scammers around and scamming messages. So some people, if you don't put your message well, they will see you to be a scammer. They will think that you are coming to scam them. So you need to find a way to put your message in a nice way that you want them to be part of your study. You want them to respond to your survey. So if they are interested, you send them the survey. So two things, you can ask them two things. They want you to send the survey to them there. That means you need to have a link or a PDF which you can upload in the DM so that they can respond. Or if they are happy, you can ask them whether they will be able to give you their emails and phone numbers. Some people will be happy to give it to you, but if they are not ready and they are not comfortable, you can still push and tell them that, okay, you just upload the PDF or you put a link in their DM. Once they click on it, they can fill the survey for you. So you gather the information about these people, their names, their contacts, and their emails. Contact, I mean the contact number, phone number. Put them together. So as many as you get, you can also go ahead and request that if they also know any other person. So for example, if I'm working in the banking industry, I'm working in the construction industry, you can ask me if I know any other person who will be interested in this survey. So you politely ask them that if they know any other person who will be interested in this survey. And this will lead us to what we call the snowballing sampling technique. So some of you have heard of snowballing. Snowballing simply means tell somebody to tell another person, tell someone, and the person will tell another person, and another person will tell another person, and another person. So we call this snowballing sampling technique. So you can get about 5 people, and these 5 people will distribute your information around. That there's a guy who is trying to conduct a survey, and I think he's a good guy. I think let's help him out by responding to his survey. Okay, so if people are happy, they will just take part. Yeah, and one thing that you have to also understand that don't be too happy from my experience. When people respond that they will respond to your survey, because some people, they will take the survey and they will never respond. Some people, you send them emails, they will never respond. And some people too, they start responding to the survey, they answer 1 or 2, 3 questions, and that's the end of it. They will not finish. So expect all these things. Okay, so you gather all these people, their emails and everything. You can also check Facebook too. So you can check all the social media platforms, and then WhatsApp. So some of you too, you are on WhatsApp platforms where some of your friends are in the construction industry. Some of your friends are in the banking industry. Some of your friends are in the IT industry. Just send them a message. Just DM them, private message, and then ask them if they are interested in taking part in your study. If they are interested, you add them to your pool, your list. So for me, for example, I ended up gathering almost about 1,500 names. But amazing thing is that I don't know whether it's sad. I don't know whether I should say it's sad. I send messages to people to respond to I send them email, because as I said, that time I couldn't go face to face to go and meet the people. So we did it through Quatrix. So I sent emails, and all these emails I sent, only I think 400 and something got back to me. Only 400 and something got back to me. And even out of the 400 and something, some of them too, as I mentioned, they start responding to the survey. They will not fill the whole thing. So I took some of them out, and that will take us to what we call data cleaning. So some of you have also heard data cleaning. So data cleaning. Yeah. So get your list. And this list will form your what we call the sample size in a way, because at the end of the day, if they all respond, that becomes your sample size. Or those who, I mean, if you take everything out, the ones remaining become your sample size. So you send them emails, or if it is possible, if you can do face-to-face, go and meet them, you give your survey, this survey that you have designed to them, they will respond. And once they respond, now you come back to do what we call the data analysis. But the first step or the first stage in your data analysis is to do what we call data cleaning. Why do you do data cleaning? Some of the people will not respond to everything. They will start a survey. Out of, let's say, about 20 questions, they will only answer only 3 questions. So before you do the data cleaning, you need to set a threshold. So you say that out of the 8 questions that I have in my survey, if somebody responds to only 2 questions, the person will be taken out. So to you, maybe you set a threshold that at least the person should fail 50% of the survey. If the person doesn't fail 50% of the survey, the person is out. So that's what you do. So you clean the data, clean it, and then you can also do some analysis. And some of the analysis that you can do is what we have outliers, and then you also do some basic statistics to see whether they are reliable, which I'll move to that stage very soon, reliable and all that. You check all these things, and if everything is okay, including criticality analysis as to whether the factors are critical or not. If everything is okay, then you can go ahead and then now conduct your factor analysis. And then the fuzzy synthetic evaluation will come in. Okay, so with this basic stuff, any question before I move on? Any question on how to go about conducting literature review, extracting the important information, putting them into your data collection instruments, and then going around administrating and collecting data? Any question? If there's no question, then let's keep going. Okay, so now we have the review was done, checklist, blah, blah, blah. Experts reviewed it, final list, we put them into the questionnaire. So like it's the same thing I've just explained. And he has just put it in a graphical form for you to understand. So first, a review was conducted, and then a checklist, which is the list of the CSFs, were extracted. And then from here, he gave them to experts. As for him, he gave them to expert directly. He didn't put them to the survey, but give them to expert. Expert look at them, and then the expert that's the pilot testing. And then after the expert looked at the factors, they commented on the factors, and then based on the comments, he used them to revise the list. And once everything was okay, then finally he put them into the survey, which is the questionnaire survey, then he distributed them. And then once he got the data from the respondents, the next thing that he did was to do the reliability and the mean scoring analysis, which I'm about to explain to you. Then from there, factor analysis and the fact that the actual fuzzy thing was conducted. Okay, so all these things have been done. Now let's come to the analysis. So now you have done data cleaning, everything. Now your data is set. So I'm going to show you an example of data. And the last time I gave you assignment, I think I sent an Excel sheet to you. Okay, I sent an Excel sheet to you. So let me check whether. Yes, so this is just an example of what I'm talking about. So you have cleaned your data, everything is ready. So your data is in this form. So what do you do next? So the next thing to do is that you conduct what we called the reliability test, which he conducted. So using the SPSS, he conducted a reliability test. And then the reliability test, what will help us to determine whether the data set is reliable, which represents the internal consistency of the data, is that we must have a clone batch alpha of 0.7 or above. If it is less than 0.7, then there's a problem with our data, which we need to go back and check our data. Maybe we need to do more cleaning to get the data right. Okay, so if you have SPSS, which I have, I'm going to import this data, which I consider it to be the final data set, into the SPSS, and then conduct it for us all to see. That's how it was done. Okay, so I have my SPSS. Okay, so I have my SPSS. There are so many ways by which you can work with this SPSS thing. So either you can decide to import the data. Okay, so how do you import? You go to File. This is my SPSS software. So you can go to File, and then you go to Import. Can you see? You go to File, you go to Import, and then you click on Excel, because my data is coming from Excel. But if your data set, put it in the form of CSV or test data or whatever, you can select that. But mine is in the form of Excel. So I'll just click on Excel, and then I come and look for the data where I've saved it. So you just go to your folder and look at where you have saved it. Let me check how I name it, data for the analysis. So I just click on data for analysis, and I click on open. So it will just import. But I will show you another way by which you can also import this. You know, okay, close it first. Save this open. So file, import, Excel, data for yeah. I just click OK, and then the data will be imported. So I've imported the data. There's another way by which you can import the data. How do you go about that? You just click this new. So I've opened a new sheet. And what you can do is that you can just copy the data. You just copy it. So I'm going to copy and come and paste, and I'll just come and paste it there. So just copy everything. And then you just come and just put it here. Yeah. So this is also another way by which you can also import your data set. So by any of them is fine. You can decide to use the import function, or you can also decide to copy it and come and paste it here. Okay, so now I have my data set. So what do I do next? So the next thing I'm supposed to do is I'm trying to check the reliability of the data set. So how do I check the reliability of my data set? So all that I have to do is to come to scale. But first, you need to click on analyze. So the SPSS has a function called analyze. Analyze, and that's where almost all the data analysis functions are. So you click on analyze, and then you come down, you scroll down to what we call scale. In a scale, you will see reliability analysis. Then you click on that. So when you click on that, it will ask you what items you want to analyze. So you select everything. So here we have 19 factors, success factors that we want to analyze. So I'll just import them to the items section. Then I can come here, do some changes or do some selection. So I want to see the scale. I want to see the items. Scale if item deleted. So it can also give you a result which we should, in case one of the items is deleted, what will be the Chrombat alpha? Okay, it can give you that analysis. So I'll select that because I want to see that. It can also give me the means. The means here means like the mean, the average of each of the factors. Okay, and then the variance. It can give me the covariance. It can give me the correlation, and so forth and so forth. And if I want to even get the F statistics from the ANOVA, which is also another thing which I will work with you another time, we can do that. So I have all these things. I can also show the correlation. I can show the covariance in terms of the inter items, like interrelations between the variables. Okay, I click OK, then I just come to say OK also here. So let's see how the analysis will go. Okay, so in summary, my Chrombat alpha is showing me that the data set I have has a Chrombat alpha of 0.953, which is highly reliable. This data set is highly reliable. That means I go far beyond the 0.7 threshold. So this data set is very good. Like if I'm looking at it from good or bad, I'll see this is extremely good for the data analysis. Yeah. Now let's look at it from individual variable, because the Chrombat alpha can also be checked from the individual point of view. So let's check each of the variables and check, because the 0.953 is when you put all the 19 together. But what about if you want to check it per variable? Per variable. So let's check and see whether per variable they will work or they are okay. So you can see also that per variable, yeah, they are looking good. Yeah, so 0.952 for the CSF one, 0.951, and the rest, and the rest, and the rest, and the rest, and all that. That means even if each of them or any of them is deleted, we'll still end up having something good. None of them is less than 0.7. So in conclusion, I will say that the data set is reliable, internally consistent, which we can rely on to conduct our study. Any question for me here? So that's how you check the reliability of your data set. Okay, if there's no question, please ask questions. Oh, everything is fine.
That's the question, Isaac. Was
Yes.
this data collected for this research project, or we are just testing with the sample data set?
It's not for any specific project, but it's for something else I'm doing. But I decided to use it for this
just sample
class.
Okay. Yeah, that's
sample.
good.
Yeah,
No
that's
problem.
Okay.
Okay. Thank you.
Thank you. Yeah, you're welcome. Any other person with a question? Okay, so now we have once again, as I said, we are using this paper as a guide. Okay, so because we are using this paper as a guide, we have to understand whatever that was conducted in this paper. Yes, we need to understand it. That's why I'm going back, because you may check another paper. They may also conduct other additional tests. That's fine, but you need to understand why all the things in this paper was conducted. I mean, they were conducted. Okay, so we have the Chrombat alpha, and it has been explained here, which 0.7 is the threshold. What was the next thing that was conducted? The next thing that was conducted was that the paper did what we call the mean scoring. The mean scoring. In fact, the mean scoring simply means the average. The mean scoring is not anything, even though there is this formula which was shown as to how to go about it. But I mean, basically, it means trying to find the average of the data set. Simple. Okay, trying to find the average of each of the variable in the data set. Okay, and there's a little bit controversy here, because with this one, it's not like the the reliability test, where we have a consensus, where scientists have agreed that a data set with a Cronbach alpha of 0.7 and above is acceptable. With the mean scoring, we don't have one. Different scholars have different mean scoring threshold. Some put their threshold at 0.25 if you are using a 5-point Likert scale. Okay, so what is a Likert scale? Okay, a Likert scale is what I showed you. This is what we call a Likert scale. Strongly agree, disagree, neutral, agree, and strongly agree. We call this Likert scale. So you can go for the 5-point Likert scale, or 7-point Likert scale, or you can go for the 9-point Likert scale, depending on the degree of responses that you are expecting from the participants. Okay, so with that, some put DS at 2.5 if it is 5-point Likert scale, and 3.5 if it is 7.5 if it is 9. But some also, with a 5-point Likert scale, I've seen studies where people put DS at 3. So they say that any factor that failed to get a mean score of 3, that factor is considered as not critical. Okay. So let me go a little bit back. As to why do we do mean scoring? I think that should be the why mean scoring? Do we really need a mean scoring? Okay, yes, we need a mean scoring. Why? Because it will help us to know the critical factors. Because here is the case where we have so many factors, almost about 30 or 35 or so. Okay, so but we want to determine the ones that participants consider to be important, very important. And you don't just determine that by just saying that. You just don't pick and choose the ones which are important. You need to do statistical analysis to determine that. So the mean scoring is one of the methods that you use to do that, to determine the factors which are important. So out of the 30-something factors, we'll end up getting to know that maybe out of the 32, only 27 are important. And the reason why they are important is that they had or they scored a mean of 2.5 and above, or a mean of 3 and above, or a mean of 4 and above. Okay, so I've seen 3. I've also seen studies where a 5-point Likert scale, some of the scholars also put it at 3.5 and above. I've also seen studies where some of the scholars, 5-point Likert scale, they put the mean at 4. So that's what I've seen. So if you read this paper, and maybe I think this paper, Dr. Wooding put it at 3. I think I'm sure about that. I think 3 or so. Yeah, I'm 100% sure. I think 3. So if you see Dr. Wooding's analysis, and then he decided to put it at 3, don't take it to be the benchmark. That's not a benchmark. Different studies put this mean score threshold at different score. So you have to determine your mean score, and you need to support it. And how do you support that? Just get 1 or 2 or 3 studies in the past who conducted a mean score for their study, and then use them as something that will back you. So if, for example, you are saying 3, you can pick Dr. Wuni's paper and say that you cite Dr. Wuni by saying that Dr. Wuni conducted this study, and then he mentioned that a mean score should be 3. Okay, so we don't have one benchmark. Different studies have different threshold for this. Okay, so is everything fine? Everyone okay with this? Good. Okay, so now the next thing is to do what we call factor analysis. Under most circumstances, when you are conducting a fuzzy synthetic evaluation, factor analysis, or I would say you don't even need exploratory factor analysis. Okay, but whether you conduct exploratory factor analysis or confirmatory factor analysis is dependent on the kind of data that you have. The data that you have. If your data is in such a way that you have already built it from literature, you have built a study from literature, and from that literature, the factors that you got, you have already grouped them. You have done the grouping. Okay. Like if you are talking about something like sustainability, there are 3 pillars of sustainability. We all know this. And the pillars are economic, social, and then the environment. We know this. So if you conduct a study and then you identify some factors and you just group them based on these 3 pillars or these 3 benchmarks of sustainability, it's okay because it's something that we have already established in the literature. So with that, it is easy for you to go ahead and conduct what we call confirmatory, because it's something that it has been done, but you just want to confirm. And confirmatory factor analysis has something to do with what we call structural equation modeling, which will be the next master class I will conduct. So my next master class with you is going to be structural equation modeling. So from either next week or maybe this week, I'll start putting out the videos on structural equation modeling. Same. Okay, so if your study has already been done, let me give you an example. I conducted a study on financial risk of PPP projects, which I published I think 2 years ago or so. In that study, this one. In that study, I grouped financial risk factors into 4. I think 4, either 4 or 3 or so. Let me check. Let me confirm so that I don't give you fake news.
Isaac, as I'm very new to this quantitative analysis, I'm a qualitative researcher. So if you could please just give talk about a little briefly about the difference among fuzzy analysis and exploratory and confirmatory, like shortly, that would be great. Thanks.
Okay, thank you. Okay, thank you. This is a very important question. Thank you so much. Okay, so the factor analysis forms the basis. The word factor analysis forms the basis of fuzzy, synthetic evaluation, and structural equation modeling. They form the basis. In other words, before you can conduct your structural equation modeling, or you can do your fuzzy, you need to conduct factor analysis. But the question is, what kind of factor analysis? That's where people get confused. What kind of factor analysis? So we have 2 types of factor analysis. We have exploratory factor analysis and confirmatory factor analysis. Exploratory factor analysis and confirmatory factor analysis. What is the difference between the 2? The exploratory factor analysis is normally conducted when already in literature we have not established the groupings of whatever factors or issues that you are trying to look at. That's exploratory. And normally with the exploratory factor analysis, when you are using the SPSS software will group the factors for you automatically. Automatically to group the factors for you. And what package within the SPSS do you choose? You choose what we call PCA, Principal Component Analysis. So in the SPSS, there is a package in the SPSS called PCA, Principal Component Analysis. The other ones, which when we are doing a factor analysis, I'll show it to you. But the one which is very prominent that we normally use is PCA. So with the PCA, which is a grouping technique, it will just group the factors for you. And this grouping, you are not the one, you don't have any control over it. It's a software thing. The software doing it for you. Yeah, it's a software doing the thing for you. Okay. And the reason why we do that, once again, let me take you back, is because normally in literature, these groupings which the PCA is helping you to establish, we don't really have them established. We have not really, you don't have sound grounding in literature as to the groupings. But if you take something like, as I mentioned to you, the PCA, sustainability pillars, already people have established, we have a number of papers, there are even theories on each of them. Economic sustainability, social sustainability, environmental sustainability. People have so many studies on that. So this has been established. And if you extract factors like that, it's easy for you to confirm. So I just want to give you an example. So with a confirmatory, I conducted this study. And from literature, I established that these are the groupings of financial risk when it comes to PPP. Oh, sorry. Just a minute. Let me take you down. So these are, based on my study, I group this. Based on my study and based on literature, I group the financial risk into into four. I said financial risk of PPP can be grouped into pre-construction financial risk, construction risk, operation and maintenance risk, disposal and disposal. With this, I can easily go ahead and conduct what we call confirmatory factor analysis.
Makes sense. Gotcha.
Yes, good. Why? Because this one has already been established. And this is normally what we know. Normally, when you read papers, you see hypothesis. I think you have been seeing hypothesis. People have hypothesis, and then they test it and they have the results. So this is my hypothesis kind of thing. So I can easily test this. And it forms part of what we call confirmatory factor analysis. But with the exploratory factor analysis, I just get the factors, then I'll just put it in the software, SPSS, and the SPSS will help me to just get the groupings. So that's the difference between the two. Okay, so when you are conducting a fuzzy, you can use any of the factor analysis techniques, depending on how you went about the factors. If the factors have already been established, then you have to just use the groupings that they have. You have already done. And an example of a confirmatory factor analysis, which was used to conduct a fuzzy synthetic evaluation, is a paper written by Dr. Akomea on PPP water project. PPP water project in Ghana. That study, the author or the authors used a confirmatory because they said, that those factors, they were already in the system. People knew them, something like that. So they just based on that to go ahead to do the fuzzy synthetic evaluation. I think it will be this paper if I'm not wrong. If not this, we'll take the fuzzy. Maybe this one. Yeah, this paper. Good. So this paper, they didn't use exploratory factor analysis for the factor groupings or for the groupings of the various factors, but they use a confirmatory. Okay, because already the factors that they were using for the analysis, they have already been grouped in literature. There was no need for them to conduct a PCA. So here, when you read this paper, you see that they didn't talk about PCA, principal component analysis. They didn't talk about exploratory factor analysis, but they talked about confirmatory factor analysis. I have a video on this. You can check one of the last video out of the 3 fuzzy synthetic evaluation videos that I did. This paper was the paper that I used to explain the fuzzy synthetic evaluation.
Okay.
So you can get more information on that. Good. But this paper that we are using, this current paper that we are using, that Dr. Wuni wrote, he used exploratory factor analysis.
Okay.
He used exploratory factor analysis because according to him.
So Isaac, just a question.
Okay.
Sorry.
Yeah, come again.
So just a question. For example, these guys used exploratory and come up with, for example, some factors, and then can someone do sort of confirmatory analysis based on this?
Yes. So if I am going to conduct another study using these factors that Dr. Wuni has put together, then mine is going to be confirmatory, because this is somebody has already done this. It's already in the system. You're not the first person you're not the first person who has extracted these factors or variables. They're already in the system. So I can go ahead and do confirmatory.
And software does for you?
Confirmatory, you have to use what we call PLS. I have PLS. PLS Smart. You need to get a SEM. Confirmatory, you can use SEM. Any SEM software can help you. But if you are using SPSS, you need to get a package called Amos or Amos. So it's a little bit different, yes. So you don't use SPS, you get what we call Amos or Amos.
Okay.
Yeah, so that will help you to get the thing done. But I mean, I prefer using Smart PLS. This is easier because the Amos, you need to go and learn some stuff, and sometimes they don't work well. But with this, it's easy to handle. I like this software, Smart PLS.
I said just one more question. Oh wow, that's great. When PLS is used and we've got a low response rate from the survey, they use something called bootstrapping, something like that?
Bootstrapping, yeah, I know bootstrapping.
Yes, what is that? And also, like they use some value with p less than 0.3 or 0.5. What is that? Can you please explain a little?
Yeah.
Thank you.
So the bootstrapping is the one that will help you to establish the path coefficients. Okay, so it's more of, the SEM has an aspect of what we call regression. I mean, those of you who did a bit of this thing, has a form of regression, and a regression is operated based on this. It's operated on this base that we have something that we call dependent variable against independent variable. So let me make it practical. So dependence, like when you are young, you are dependent on your parents. Your parents are independent. They don't depend on you. So whether you eat in the morning or you eat in the evening, it depends on how much your parents earn. If they don't get money, it means you are not going to eat. So you are dependent on them. But your parents are independent. So whatever will affect your parents, indirectly or directly, will affect you.
Yes.
Good. So that's how this same thing it works. It's with the bootstrapping. Bootstrapping will help you to establish that what is the relationship. So if you are taking like a factor like, let's say, economic sustainability, what is the impact of economic sustainability on social sustainability? In other words, you are trying to determine which one depends on the other one, and if one of them depends on the other one, what is the extent of dependence? You get a point. What is the extent of dependence?
Yes. I got that independent and dependent variable. For example,
and then you talk about P, right?
Yes, I'm talking about P. So what bootstrapping does first, could you please explain?
So what bootstrapping does is to help you to establish whether there is I mean, let me use the proper statistical term. It's called causal relationship. That's what I wanted to say. Whether there's a causal relationship between the two variables. Causal, like as I said, it depends on your parents. If they get money, then it means you are going to get money. If you are broke, that means you are not going to eat. There's this causal relationship. Whatever affects your parents, indirectly or directly, will affect you. So there's this causal relationship. Or what will lead to maybe more money means you can invest more into properties. Less money means you can't buy water to drink. So it's just trying to help you to establish what we call the causal relationship between the variables. Yeah. So I'm just going to show you one example. So just this one. So you can see the arrow. Let me take. So for example, if you are trying to look at what is the impact of critical success factors on financial performance, can you see the causal relationship? So this is the value,
Yeah.
showing that it's 1.377. But the next thing that you have to identify is, yes, there is a relationship. But what is the
Yes.
extent of the relationship? Is it significant or is it insignificant?
Yeah.
So the significant or insignificant will lead us to the P that you talk about, the P values.
Okay. Okay.
Yes. So we have a threshold. If your significance level is less than 0.05, you either determine it is significant or insignificant, depending on the kind of null hypothesis or the alternative hypothesis.
Okay. 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 So that means if its p-value is less than 0.05, that means the relationship between those two variables is insignificant.
It depends on what you have set, because I cannot
Okay.
give you a direct answer in a sense that it depends on what you have set and what you are looking for.
Okay.
Yes,
Mhm.
it depends on what you are looking for. Yeah. But as I said, don't worry. This is another videos. I have a number of videos coming out.
Yeah,
You
yeah,
can
sure.
watch more on this. Okay, so once again, this analysis is good for confirmatory. So let's look at something. If you are looking at PLS, so you can see factor here. So I can use the smart PLS to establish the confirmatory factor analysis of the variables I'm looking at. All that I have to do is just select factor and then click start, and then it will analyze it for me. So I like using the smart PLS. I can also use Amos, but I prefer using the smart PLS. Yeah, and then based on this, now you can determine whether the factors are important or not. And you determine the factors are important or not by looking at what we call the factor loadings. So the factor loadings too, you need to establish your threshold of your factor loadings. So in literature, 0.7 and above is what is acceptable, but there are situations where people have mentioned that you can use a factor loading of 0.5 or 0.6. That's also acceptable. Yes, Kenneth. Yes, you raise your hand. Kenneth, go ahead. Kenneth, yes, you can ask your question. I can see that you have raised your hand.
All right. Thank you. Please, with regards to the factor loading, sometimes when you have a value less than 0.7, and then, because I think I've come across literature that says that if you get something that is less than 0.4,
0.7.
yeah, you're supposed to delete that particular factor loading so that it doesn't affect the whole thing.
Yeah,
But
but
sometimes,
to not to cut you short, just to add to what you said, yes, you can do that, but there's also a serious debate on that issue. There's a serious debate because some people also think that it depends on the kind of data that you are looking at and also what you are looking for at the end of the day, the output. Because I've also seen studies where people have gone as low as 0.3 as an acceptable factor loading. 0.3.
okay,
Yeah, so.
sure. But then my question was, sometimes if you delete a factor loading of like 0.6, it's automatically affects the other factor loadings.
The other factors, yeah.
Yeah, so I was going to, or I'm asking whether it is necessary to like delete the factor loadings.
Where it is necessary, I think you have to do that. Yeah, where it is necessary. But a situation where you look at, so for example, when I'm running any analysis, some of these analyses that you see here, the factors were more than this. I've run this many times. I've run this many times before I arrive at this resource. So what you have to do is that if you run it and then you think that one factor, if you delete it, is going to cause a problem, just leave it. And then when you are doing your interpretation, when you are explaining your resource, you have to justify why you kept that factor, which is, let's say, 0.4 or 0.3 in your analysis. So just get a paper, get some papers, some literature to support why you think that it's justifiable. Like even in my PhD thesis, I mean, there were some of the factors. I had a lot of factors that I analyzed. Some of the factors, I think some of them were even 0.3 and all that. And I included them, but I justified them. And when the examiner's comment came, they are fine. I said, that's okay. So you need to justify, because some of the factors, as you rightly said, you take them out and it will mess the whole thing up. Everything will be messed up. So just leave it and justify it. But always the ideal, the best thing is that if it is not good, take it out. Yeah, thank you, Kenneth, for your question. Any other person with a question? Okay, then let's keep on going. I think we need to run a little bit faster, so that we don't spend too much time, because there are other things. I mean, there are so many other things that we have to look at. Okay, so now we have our mean scoring, and based on the mean scoring, we have been able to establish the critical factors. The next thing is to conduct the factor analysis. So how do you go about conducting factor analysis, and why factor analysis? So factor analysis is a factor reduction technique. Why factor reduction? Once again, it will come back to what I was talking about in the literary review stage. Here is the case where you have extracted so many factors. There are situations like, I mean, those of you who know this, I mean, this study that we are conducting, Collins will confirm this. We extracted more than 100 factors. 100. So Collins, if you are working on these 100 factors, you can't put all these 100 factors into your analysis. You need to find a way to take some of them out, because I mean, definitely some of them will not be important. Okay. And then also, not only that, you need to also find a way to group. If there are many, you need to find a way to group them so that it will make it easier for you to analyze and talk about them. Because here is the case where you're having about 100 factors. There are too many. Why don't you put them into compartments, into groups, and talk about them? That will make it easy or easier. That's why even when you come to class, Dr. Roxana will confirm this. Like, she's handling over 300 students. These 300 students, if you give them assignment, sometimes it's difficult. So normally what we do is that we tell them to form groups. Okay, you form groups, and out of the 300, you may end up getting about 10 or 20 groups. It's easy to mark 20 group assignment, because all these 20 people in the group, they will present just one assignment. Imagine marking 300 students scripts. It's not easy. It's not going to be easy, right? But if you group them, you make them form groups, and they are 20, 20, 20, 20. Hello, sorry, a little bit of break. Sorry about that. So if you have 20 groups, you have grouped the 300 people into 20 groups. It's so easy for you to just let them submit their assignment, 20 groups, and marking 20 scripts is far easier than marking 300 individual scripts or papers. So a method, a technique, a statistical technique that can help you to do this if you have so many variables. It's what we call factor analysis. So factor analysis is a factor reduction strategy. It's a factor reduction strategy, which will help you to put your, there's so many factors that you have into clusters, which you can call them groups. Yeah, and it has been widely used in so many studies, and we all know this. Some of you have done, you are still using factor analysis. But there are certain conditions that you have to meet with the factor analysis. The first thing is you need to determine the type of factor analysis that you are using. Dr. Woodin didn't mention that, but I know. I mean, I know what he did, but he didn't mention. But the first thing normally that you have to do is you need to mention the kind of factor analysis that you are using. We have two main types of factor analysis. Either you use a confirmatory factor analysis or you use a exploratory factor analysis. In this context, in this paper, the exploratory factor analysis was the one which was used. Okay. Then once you determine the type of factor analysis that you are using, the next thing is you can go ahead and conduct the reliability test again. This time around, the reliability test that you are conducting, it should be on the critical factors. Remember, when the data set was collected and it was collected and claimed, we did some kind of pre-testing or preliminary testing. And one of the things that we did at that stage was to use the reliability test to check whether the data set is okay. That was when you had all the data, let's say 25 variables. But at this point, you are conducting or you're going to conduct the reliability test on the critical factors after you have utilized the mean score to determine the critical variables. So that's the difference. But I think in this context, it happened to be the same because I think the same variables that you got at the pre-testing stage of the data set, they were the same data set that he went ahead to use them for the factor analysis. Okay, so the next thing to do is to do what we called normality testing. Can you hear from me? It seems there's a little break, but is everything okay? Hello?
Yeah, please, we can hear you.
Okay. Okay, good. Okay, great. You can hear from me. That's good. Okay, so now the next thing to do is to conduct what we call a normality test. Okay, thank you. Thank you. Thank you so much. The next thing to do is to conduct what we call a normality test. So with respect to the normality test, you can use the Shapiro-Wilk test. You can use what we call the Shapiro-Wilk test. Or you can also use the Kolmogorov-Smirnov. Kolmogorov-Smirnov. Or Shapiro-Wilk test. Okay, so you can do that. So if you want, for the sake of time, I'm sorry, I think that for now I have to cut some of this so that we can go straight to the fuzzy analysis, because if I don't take care, we'll spend a lot of time here today. If you want to get more about the Shapiro-Wilk test, I have a video on that. It's I think the second factor analysis video that I shared with you. Go to my YouTube channel, it's there. Get that. I did a Shapiro-Wilk test and Kolmogorov-Smirnov. Kolmogorov, I want to show you the Kolmogorov-Smirnov. Okay. You can use the Shapiro-Wilk test or Kolmogorov-Smirnov test. So please take note. Get more about this. I'm cutting some things short for the sake of time so that we can get into the fuzzy and then go home, and then we'll spend more time. If you want to get more, get that paper, that video, watch it, and then get to know how to conduct a Shapiro test. Why do we conduct Shapiro test? That's the main question that you need to ask. Okay, Alidu, your hand is up. Ask your question.
Yeah, Doc, please. I just want to know if for all these tests we can get it from SPSS.
Yes, they are all in SPSS. Okay. So once again, I encourage you check my video. I conducted all of them in SPSS. They are all in SPSS. So I've taken my time step by step. That one to take some time. And so I'm just trying to cut some.
All right, that's fine. I just want to know. So maybe we'll explore the final.
Yes, kindly get this in my second factor analysis video. on my YouTube channel. Yes,
Okay.
I have a special video on this. Get to know how to conduct the Shapiro-Wilk test and then the Kolmogorov-Smirnov. The question is, why do we conduct this? The reason why we conduct this test is to help us to know whether the data set is normal or not. So this test is extremely important. The reason why it is important is that when you determine that your data set is normal, there are certain statistical methods that you have to use to analyze your data set. And if your data set is not normal, there are certain statistical techniques that you have to use to analyze your data. But the question once again is, okay, so I know my data set to be normal or not normal. So for what? Why do I need this? The reason why you need this is that at this point you are trying to find out the views, the differences in the views of the participants. Okay, because let me take somebody that I lead in Collins. If I give the two of you questionnaire, you all respond it differently. You have different views about how things are supposed to be done. So your responses will be different. If somebody is coming from academia, the person will see, or the person sees things different from somebody who is working in the industry. So when you give these two groups of people a questionnaire, they will respond differently. So at this point, we want to know that what is the extent of the differences in their views? What is the extent? Is it like, do they all agree or they don't agree? Like, for example, if you say, oh, Ghana is rich. Ghana is a rich country. Advanced. We have Nana Akufo-Addo. It is Kasoso Kobdi. Sorry. Like if you say that Ghana is rich, definitely some people will say that, oh yeah, indeed, Ghana is rich. Yeah, you're right. Yeah. Yeah. Some will also say something different. They say, no. I don't think Ghana is rich. You know, some will say that, oh, Ghana is, and this is influenced by the political affiliation that you subscribe to sometimes. And even nowadays, even a little bit of analysis I've done myself, even nowadays, even tribal things also come in. Politics, tribal politics. There are people who are in Ghana that maybe currently things are not going well, but because of the political affiliation or the tribe that they are coming from, they will never admit that things are not going well. And there are some people too, when things are going well, they will say that things are not going well. So it's like that. So differences. So at this point, we want to find out the views of the people as to what they think about the survey that we conducted. And this will help us in doing this normality test. So do a little bit of normality analysis as to what your data set is. If you conduct the Shapiro-Wilk test and it comes out that your data set is normally distributed, then it's good. You can go ahead and use statistical data such as ANOVA and then other student t-tests or simple t-tests. And because, the reason why you are using all these tests is that they form part of, if the data set is normal, they form part of what we call a parametric statistical analysis, parametric. So another assignment I'm giving to you, which I'm not really going to spend time on, is go and find out the difference between non-parametric data analysis and then parametric data analysis. If your data set is normally distributed, we consider it to fall within what we call the parametric data analysis. And then if your data set is not normally distributed, they form part of what we call the non-parametric data set. And if your data set is non-parametric, then there are certain data analysis that you have to use. Okay, so if you pick something like, if you want to get the views of people, normally if your data set is parametric, normally distributed, you go for ANOVA. or sample t-test to get to know the differences of people. But if you immediately your data set is non-parametric, then you need to look for the opposite of ANOVA and opposite of simple t-test. So the opposite of ANOVA, the opposite of simple t-test, and the rest are examples include the Mann-Whitney U-test, and then Kruskal-Wallis. So this is also part of that video that I mentioned to lead you. Get that. I've also done a thorough analysis of that in that video. Watch it. So Kruskal-Wallis, and then also the Mann-Whitney, they form part of what we call the non-parametric statistical data and techniques. So in this paper, you can see that when the authors conducted the normality test with the Shapiro-Wilk test, they established that the data that they were working with, the data set, is not normally distributed. Because it's not normally distributed, then they went ahead to use the non-parametric statistical techniques for further data analysis. So what they chose, what they decided to use is to use Kruskal-Wallis. And why Kruskal-Wallis? Kruskal-Wallis help us to establish the differences between the response to the views of the respondents. So if this data set was to be a parametric, then we'll go for ANOVA or MANOVA. So some of you have heard MANOVA, ANOVA, and all that. So the Kruskal-Wallis is just the opposite of the ANOVA, MANOVA, and all the NOVAs. Analysis of variances. Analysis of variances work with ANOVA. A question for me? Yeah? Okay, no question. So as you can see, they said the Kruskal-Wallis test was conducted to determine whether there are significant variation between the responses of the experts from academia and industry. And they did that. Okay, so and the results is here. The results is there, so you can read more about that when you get this paper. So all these tests were done. Then the next thing to do is to do the actual, all these things are just preliminary tests, to do the actual factor analysis. So with the actual factor analysis, these are some of the things that you see, which I'll take you there, the software. So you see what we call the KMO. You see the Bartlett test of sphericity, and then other things. So I'll just take you there in the PCA, they will all come out. So let me take you to the SPSS. So in the SPSS, you click on analysis and you go to dimension reduction. And in the dimension reduction, you click on factor. When you click on the factor, it will ask you what variables do you want to analyze. So you just pick them, you bring them here. But within the variables or the functions on the variables, you can decide to check, or you can decide to take the descriptives that you want to see. So maybe you want to see the coefficient, the correlation coefficient. We want to see the significant levels, determinant, the KMO, and then maybe the univariate descriptives. You can click continue. When it comes to the extraction is where you do the actual, we want to know the extraction method. So this is where we want to know the groupings. So by what means can we get the groups, the factor groups? So we can decide to go for the PCA, which is the principal component, and others. So I think I mentioned this. There are other methods that you can use to get the factor groupings, the groups. In other words, if you want to group your factors, the software can help you. And you can decide to use a PCA or this or that and all that. But the one which is very popular that we use a lot is the PCA, principal component analysis. So once again, I've seen somebody ask me, so the PCA is not, normally it's not something on its own. It's kind of a form part of the factor analysis. It's an extraction method in the factor analysis. I mean, exploratory factor analysis. So you check that, and then we also want to see the scree plot, because the scree plot will tell us the number of groups that we will extract. And then we also want to know the eigenvalues. Normally, the eigenvalues should be greater than 1. Okay, so we have this. Rotation. So the rotation is something that you need to also establish. What kind of rotation do you want to go for? Varimax, direct oblimin, quantimax, equalmax, and promax. The one which is very popular that we use is the Varimax. Okay, so you can click on that, and then you come to the options. So the options, you can decide to sort your results out. You can decide to sort them by the size, and then you can also decide to suppress some of your variables. You can say that any variable which is more than, which is less than 0.3 should not be shown on the table. Or you can decide to say maybe 0.4, 0.5, or whatever. It depends on whatever you want to choose. Okay, so I have all these things done. Oh yeah, so I click on it, and then I get my results. So so let me go straight to the groups. So what I can see is that I get only 2 groups. I was able to extract 2 groups from this 19 variable, which is fine. That's okay. And then the cumulative extraction sums of square loadings is fine, which is 60%, at least 50% and above is acceptable, 60% okay. But if you get 70, 80, extremely good, that's fine. So in other words, I have only 2 groups. Now let me go to the rotated matrix and see the factor loadings and which factor is in which group. So you can see here that the software has automatically given me the groups that the factors belong to. So it is automatic, the rotated component matrix that's giving me. So you can see that the CSF 10, 15, and all that, they all belong to factor 1. Or group 1. And then CSF 2, 1, and 3, and all that, they belong to group 2. So here, you can decide to apply what Kenneth asked me, the factor loadings. So here, you can decide to say that, okay, any factor loading which is less than 0.7, I'll take it out. 0.4, I'll take it out, or whatever. Yeah, so, and then there are situations where you have something like this, where you have one factor which you can find its factor loading in factor 1 at the same time. So the question is, okay, so do you put it in group 1 or you put it in group 2? I'm sorry for a little bit of internet challenges a bit. I don't know what's going on today. Sorry for that. Yeah, so a situation where you have one factor, it has an aspect of it in group 1 and also in group 2. So where do you put it? So you have to determine. And how do you determine that? Just pick, put it in the group where the factor loading is bigger. Yeah, so that's it. So we have our groups set. So I can extract this straight up, copy this, and come and put it in my Excel. So now I have my groupings, and the fuzzy can begin, because we will need this, or this is very important when it comes to the fuzzy analysis. So I have my groups. Group 19, there's nothing for group 19. Yeah, so I have my groups. This. Yeah, So these are the groups I have. Then the next thing to do is you have to give it a name. That's also another thing that make the exploratory factor analysis a little bit different from the confirmatory factor analysis. But with the exploratory factor analysis, you have to give the factor groupings names. You have to give it a name. Unlike confirmatory factor analysis, where you have already established the factors and then the group names, or the group names have already been established or something. But with the exploratory factor analysis, once you are done and you have your factor groupings, you need to give it a name. So the question, what name do we give to that? Before I answer that, let me go to what Gosway want to ask. Gosway, you can go ahead. What's your question?
Okay, I wanted to find out, sorry, I wanted to find out if you pick the highest, rotated component, component, yeah. If you're having two, for example, in our case, we had, I think, C, the component
like this.
Yeah.
Like this.
Yeah. Won't it affect any value? Actually, we saw from one table before we came here how that the cumulative value had. We saw the cumulative value. Don't you think that picking one from or selecting one would affect that value? I don't know if you get it.
Yeah, I get your answer. I mean your question. Yes, it will not affect because at this point you are trying to determine where the factors belong to. Just you want to determine, and you are torn between two issues as to whether to put it in group 1 or group 2. So what do? So you just pick the factor loading, which is higher. The two of them, you just check them and then you pick the one which is higher. And then you put it at where that factor loading is higher. So for example, if you take CSF4, the factor loading of CSF4 in group 1 is 0.553, and the one in group 2 is 0.599. So all things being equal, you just pick the 0.599. Yeah. Is it okay? Is it okay? That's not okay.
Yes, it's cool.
Yes, it will not affect anything because at this point, what you are trying to determine is you just want to know where the factors they belong, which group. Yeah, you just want to know where they belong. Yeah, you just want to determine that. It will not affect because when we get to the next level, the next point, what we have to do is we'll do some kind of analysis, and even with that analysis, still it's not going to affect. Yeah, it's still not going to affect because you can't have two factor loadings for one variable at the same time. It's going to sound a little bit some way. Yeah, that's why we end up just picking one of them because it's just like a human being having two heads. A human being having two heads. It's to look some way. You look a little bit funny. Yeah. So just pick one and leave the other. It will not have any effects on the other one that you drop out. Yeah. So this one, because I don't know, there's no way CSF4 can be in group 1 at the same time group 2. Then maybe you need to go ahead and do some kind of analysis on intersection. You did a little bit of Venn diagram. I think all of you did that Venn diagram. So if if that's the case, it's going to be like you need to do some kind of intersection analysis. And yeah, which is also another thing, is going to bring a whole lot of, you don't need that at this point. So just pick one of them and move on. Okay, so thank you, Gosway. Let's keep on going. So we know our groupings and then we know our factors. So what next? The next thing is give it a name. Please, here, give it a name. And it's so hard because there are situations where you're going to have all different factors with different names. So how do you determine that? That's one of the things. This is where you need to bring out your skills, in terms of your academic skills, where you just determine the names of something. You're just trying to name a child, name a school, name your house, name something, name this, name that. So the question, what name are you going to give it to it? Okay, so what will inform you to name this, these factors, give it a name, that group a name, is look at the individual variables in them. So you look at all of them and you can see that, okay, looking at these factors critically, I'll give it a name, economic sustainability. Just an example. Because I think if I look at this or that and all that, and sometimes what will also inform you is that maybe out of 8 variables that you are looking at, it seems 4 or 5 of them, they are all heading towards a certain direction. They are all heading towards economic sustainability. They are all heading towards social sustainability. Then give it a name, social sustainability. So here you need to bring out your skills, and that's one of the things that makes exploratory factor analysis a little bit difficult, unlike confirmatory factor analysis where we know the names already, the names of the groups already. Okay, so you have to do that, and let's see what Dr. Wune did briefly so that I can use that to explain it to you. Okay, so you can see that, yeah, he got these names. Yeah, so the names are here: adequate technical capability and infrastructure based on the factors that come under them: CSF1, CSF8, CSF12, CSF10, CSF16. Then the second group, he gave it a name: effective stakeholder and supply chain management, based on the things that are in there. And then there is there's something that somebody informed me some time ago. I want to tell you, but I don't think it's right. Okay, because you can be questioned. But I there's something I want to say. I did some factor analysis for someone, and the person told me that, but Isaac, you can easily pick some of the factors, which is not right. Once again, I want to say this: so don't do it, because somebody can question you. The person said you can easily pick some of the factors from here. Let's assume some of the factors here is about interest rate, inflation, and all that. And there are also some factors here about unemployment and all that. Okay, so you can pick the factors and just put them together and then give them a name: microeconomic conditions or microeconomic policies. That's easy. That's good. A case where the same value in, let's say, group 1 and 2 for a particular component. Please, with the highest rotated component, can there be a case where there is the same value, let's say group 1 and 2 for a particular component? The same value, let's say, okay, we are talking about a variable, right? That is, who is this? Let me address you well so that, okay, Sebastina. Are you talking about, for example, you have, let's say, 0.773 and also have 0.773 in group 2? Is that what you are talking about? Oh yeah, yes, it's possible. Yes, it's possible that the factor loadings can be the same, but the good news is that the variables are not the same. As for factor loadings, they can be the same. So you can have something like 0.773 in group 2, and that 0.773 is for CSF2. And this same 0.773 is for CSF10. The two variables are not the same, even though they are having the same factor loadings. Yeah, so if the factor loadings can be the same, but it's possible that, and sometimes the issue is that, these factor loadings, they have been reduced to 3 decimal places. They have been reduced to 3 decimal places. It's possible if you expand the decimal places, there will be something that you will see that will differentiate between the two variables. So it's possible one of the factors, their factor loading was rounded off or rounded up or whatever we call it to get to the 0.773. That's why they are the same. Because if you expand it to, let's say, 0.0000, let's say to 10, when you go, you see something that would differentiate between the two. Because they have been rounded to 3 decimal places, maybe that's how come they are all have. You can see that they all having the same. Yeah. So don't conclude that because they are the same, then there is a problem. Therefore, you are going to take it out. No, leave them. If the variables are not the same, just leave them, because maybe there is something that the software is not showing you which differentiate them. So leave them as they are. Yeah. Okay. Any other question? Mr. Pam Fukweju. Yeah. Any question, Mr. Kweju? No question. Okay, so let's keep going. So the names were given, and these names, they were given based on the items or the sub factors or the subgroup factors that came under each of the groups. So he gave them the names. But as for the factors, their loadings were generated by the SPSS software. Okay, so these are the factor loadings, the eigenvalues, then the percentage of variance explained, and the cumulative variance explained. And you can get these things from here. If you look at the SPSS, they are in this table. You can pick them from here. Each factor has their cumulative variance explained and all that. So they are here. You can pick them from here. Okay, so what's the next thing? So once we are done with the factor analysis, then we can go ahead and do our fuzzy. So I'm going to make it brief and straightforward so that we can save some time and then go. Yeah. Okay, so let's go into the fuzzy. So now we have our factor groupings and we have our factors. So what's the next thing to do? So the next thing to do is that you need to do what we called the calculation of the weights of each of the factors. And also you need to also compute the weight for the group. So 2 things that you are supposed to do. Calculate the weights of each of the factors. The factors, I mean the variables, which we established from the factor analysis. And then also calculate the weight for each of the groups. So how many groups do we have? We have 1, 2, 3, 4. So he determined 4. Okay, so the question is, so how do we determine the weight of the groups? Very simple. So what you have to do is that you need to pick the factor loadings of the groups. So you have to pick the factor loadings and then put the factor loadings together. Okay. So pick the factor loadings and put them together. That's one approach. Another approach is that you can also decide to go for what we call the mean scoring approach, where you can also decide to put their means together. So you pick all their mean scoring from the mean scoring table that we did, and then you can put them together. Then there's also another approach where you can use the analytical hierarchy process, AHP. So if you want to determine the weight, we have, at least I know 3 of them. You can decide to use the factor loadings 1. You can decide to use the mean. You can use the AHP and others. But what is very popular and common that many studies have already used is that they use the mean scoring. The mean scoring. Okay, so we'll go back to the mean scoring table. So this is the mean scoring. The MS here is the mean scoring. So with the mean scoring, you need to find out the mean score of each of the factors. Okay, so without bothering you, let me go back to my table, my SPSS, and just copy the mean scores and the standard deviation and all that. I'm going to copy this. I'll just copy this. I'll just come and put it here. Okay, good. So I'm going to put the means here for the sake of time. I just don't want us to waste time. So check through CSF 10. What is the mean? 4.4, right? 4.4, 4.44. What is the mean score for CSF 15? 4.38. 4.38. What is the mean scoring for CSF 7? Is the mean 4.33. What is the mean score for CSF 18? So we come down, it's 4.29. What is the CSF? What is the mean for the CSF 9? It's 4.3. What is the mean score for CSF 16? It's 4.2. What is the CSF 8? What is the mean? 4.28. What is the mean for CSF 5? It's 4.29. 11, 4.15. 14, 4.24. 6, 4.24 again. Now we come to the CSF2. CSF2, what is the mean? 3.98. CSF1, 3.9. CSF3, 4.07. CSF4, 4.22. CSF 13. What is the CSF 13? 4.04. What is the CSF 17? It's 4.09. And CSF 12 is 4.07. Good. Great. Now that we have this, I'll just wipe this away because we don't need it again. We have it, so there's no need for me to keep it. Let me wipe it. Yeah, so away. Good. So now we can determine the weight of the groups. So this is for the mean for individual variable. Let me make it this MV. Okay. And then we'll determine the weight for the mean of the groups, the group in general. So MG. Okay, so here what we will do is that we will sum up all the mean. Okay, so what we'll do is that we'll add the mean of the group together. Okay, I'll add them together, I'll sum them up. All the mean score of group 1. Remember, all these are group 1. So give us the total of this. So with this total, I can easily determine the individual weight. How do I do that? You just pick this figure and you divide it by the total. You pick this figure, divide it by the total mean of the group. You pick this figure, divide by the total of the group. Pick this figure, divide by the total of the group. You pick this figure, divide by the total of the group. You pick this figure, divide by the total of the group mean. You pick this figure, total group mean. This figure, So I'm determining or I'm establishing the individual weight or the variable weight. Please, any question here? I just want to make it simple and straightforward so that you understand it. I don't want to use some complex statistical words which will make it difficult for you to understand. So first, get the mean score. Okay, get a mean score from the mean score table, or just get the average of each of the variables. Okay, and then all the averages or all the mean score within a group, because all these are in group one. These people, the yellow people, let me make them yellow, and let me make these people green. Red, yellow, yellow, green. Ghana Black Stars. Hey. Red, yellow, green, and red, yellow, Black Stars. Okay, so all the members in the in group one, you add their mean together, their mean score. So these are the yellow people. Yellow CC, they for corner. For you. Okay, so you add all here 47.14. Oh no, the network is so bad. What's going on? So you just pick the mean and you divide it by the total group mean. You pick each of them. You pick this, each mean score, and divide it by the total group mean. Okay. Now let me do it this way. Let's see whether it will work. This will not work because this is what L15. 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 This is L15. 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 This is L15. And this is L15. And this one to L15. Okay, so I have the individual weightings for each of the variables in group one. Okay, so this is group one. So I'll call this group yellow CC. Yellow CC, day for corner. That's the name. And then the group two is called green contumely. Hey, sorry, cocoyam leaf. I call it leaf. Sorry for that. Okay, let me call this one good, please. Not acceptable. Good from Obuasi. Okay, so that's it. Now let me come to the second group. With the second group, you need to establish the total group mean. Total group means that you need to add all the means together from that group. So sum all the mean score. Oh no, what's going on? So add all the means in this green leaf together. Now establish each of the weights of the dose in the green group. So you pick this one, then you divide it by the total group mean. You pick this one, Then you divide it by the total group mean. You pick this, divide by the total group mean. You pick this, divide by the total group mean. You pick this, divide by the total group mean. You pick this, divide by the total group mean. Then you pick this, divide by the total group mean. Please, is this okay? Is there a question here? If you have a question, you can ask me. Okay. Okay. So now that is the group mean, and then we have the individual means. Okay. I mean, individual, let me make a group mean score. And let me make this I, individual or variable means. Okay. So what we have to do is that now we have determined the individual weights. We need to determine the group weights or group weightings. How do we determine the group weighting? So here, what we have to do is that we have to sum up the two group means together. So we have group 1, the total group mean is 47.14. Then we add it to group 2, which is 28.37. You add them together, total, to give you 75.51. So it is easy for us to determine the group mean from here. So all that we have to do is we pick this group mean, which is for group 1, then we divide it by the total of the two groups to give us this. Then we'll pick the second, then we divide it by this, and that will also give it to us. In other words, what you are supposed to get is that in each group weightings, when you add up or you sum up all the group weightings, it should give you 1. So if you take group 1, if you sum up all these weightings, it should give you 1. This one to 1. And then when it comes to group weightings, when you sum up the two group weightings, it should give you 1. Is that okay? Any question? Is everything fine? So we have determined, we have established the individual weightings and then the group weightings. Okay, good. If there's no question, let's keep going. So what is the next thing to do? The next thing to do after you have determined the weight is that you need to determine what we call the membership functions. Membership functions. Membership functions. Membership functions. Okay, so with the membership function, what we normally use as a basis to determine the membership function. So please here, get it very well and get it right, because this is where most people get confused. With a membership function, we need to pick each of the variable. And when we pick each of the variable, we need to know how respondents responded to that individual variable that we have picked. So I'm going to give you an example. So if I pick a variable like CSF10, okay, I need to go back to my Quatrix or my survey database or whatever, or survey monkey. Then out of the CSF10, you know, the CSF10 was ranked according to the 5-point Likert scale, 1, 2, 3, 4, and 5. So CSF10, my question is, so what is the percentage of people who ticked 1 from my responses? And you need to know this. How do you know this? Just go back to your database. It's easy to determine this. So maybe out of the, so I'm going to give a number, just a number. This is just an example. So out of the 200 people, so these are the 200 people responded to the survey. Out of the 200 people who responded to the survey, 20 of them ticked 1, which represent strongly disagree. And then 45 ticked 2, which is what? Disagree. 30 ticked neutral. Then how many left? There's 75, 95. We have 105 left. So out of this, let's say 50 ticked agree. And then the last one is, how many left? So 20 minus this, minus this, minus this, minus this. So 55. So 55. So 55, take, oh, anyway, it's more important. 55. So 55 take strongly agree. Okay. So with this, you can easily convert them into percentages. It's easy. How do you convert this into percentage? 20 divided by 200. I mean, into decimal places or percentages or whatever you want to say. And then this divided by. So I'm trying to determine what we call the membership function. So I'm trying to determine the membership function for a factor called CSF10, a membership function, MF. Okay, so this divided by 200, this 30 people responded, that responded 200, this, and this divided by the 200, and this divided by 200. Okay, so for me to write my membership function for CSF10, it's going to be very simple. 0.1, 0.225, 0.15, 0.25, and 0.275. So this is how we determine the membership function. Please, any question here at this point? This is a very important aspect of this exercise, because if you don't get this part right, it's going to affect the other parts. Any question? Everyone okay? Hello? Hello, hello. Hey,
Yes.
are people online?
Yeah, so we are there.
Okay.
Yeah.
Okay. Okay, good. But is there any question here with respect to how to determine the membership function?
No, it's very clear.
Okay, so this is how you determine the membership function. So you do the same thing for each of the variables. Okay, each of them, each of the variables, depending on the on how respondents responded to your survey. Okay, so I'm just going to put this one here, and I have one I did with some people. Let me copy that so that we can go faster, because if I'm going to do this one by one, we are not going to finish. Take some time. Let's see, we get this. Let me get some membership function from here. Okay. Oh no. Okay, yeah. Okay, it's from here. Good. I'm just going to copy this just for our analysis sake. But this just want something which we can use to do our work. So I'll put these membership functions here, MF. No. Okay. See, there's a little bit of a problem. Anyway, okay, so the goal is from here. Let me use the responses. And then I'll put them there. Let me use the responses rather than we calculate, but that will take us a long time to get there. Okay. Let me make this. Let me just copy one of them and put there. Okay, so with this, we can determine the membership function of each of them. Yeah. So how do you do that? You just find the percentages of each of them, or the decimal into decimal places. So you pick this, then divide it by 96, and do the same thing for all of them. 1, 2, 3, 4, 5. Bring them down. And this divided by this. This divided by 96. And then this divided by 96. And this divided by 96. Yeah, I don't need this. So with this, I can just scroll it down. Yeah, there's nothing here. $12.49, 30, 96. Okay, then let me yeah, okay, so these become your membership function. Okay, so we have the membership function for each of the items that we are dealing with. So we have the membership functions here. So what do you do next? The next thing is to now compute. Okay, yeah, Ali do.
Yeah, please. In the membership function, you said we have to identify the individual responses, as in how many people ticked one and others. And you mentioned that you can easily trace that from the analysis. I don't know where you can get that information.
Yeah. Come again.
Okay, so I want to know where you can get the information that will help you get the
Membership
function.
function.
The
Okay,
percentage.
so the information where I mean where you can get your membership function information is go back to the respondents. I mean where you kept your respondent information. I mean as to how people responded to your information or the survey that you sent out there. So if you pick each of the variables, you count, and this is what it's a kind of work. You count the number of people who responded. So let's assume you gave your survey to 96 people, 96. So out of the 96, if you pick a factor like CSF 10, you ask yourself, how many people ticked? They ticked 1. So as you can see here, there were 6. How many people ticked 2? So here, nobody ticked 2. How many people ticked 3? There are 18. How many people take 4? There were 46. How many people take 5? There were 26. Total, you have 96 people who responded to the variable.
So this one, you have to do the manual counting.
You have to do the manual counting. Yeah.
Okay, that's what I just want to know.
Yeah, you have to do manual counting. But I think if you have the quadrics and all that, I think it will be easier for you to get this information. Yeah, I think so.
Okay.
But still, you need to do the manual counting. Okay, so you are okay, Alidu?
I'm okay. Thank you.
Okay, you are welcome. Just let's give ourselves 5 minutes break so that I can fix I want to change where I'm sitting so that I can fix my internet because it seems it's going up and down. I'm not happy with what is going on. So just 5 minutes. Yes, just 5 minutes. Take water and then just 5 minutes.